Hello, welcome to section 12.3. Here are the answers for 12.2. You may have done your problems differently, and that's because the way I kind of taught you guys how to do these problems. So if your work looks different than the one the book has here, that's totally okay. Probably saw some trigonometry within some of your problems, just like in chapter 11. Maybe saw some Pythagorean theorem in there. Alright, we're going to be talking about pyramids and cones today, and just like yesterday, there's a ton of vocab here. Here's what you guys need to know. You need to know the lateral edge, the lateral faces. You got your base here. You got a regular pyramid, and we're probably not going to see too many pyramids. They're very challenging to come up with the surface area because you have to find the area for triangles, for different triangles. With regular pyramids, all of the triangles will be the same because the base is a regular polygon. So, like I said, take what you want out of your other vocab, but there's really just a lot of stuff that you guys don't absolutely need to know here. And then the other things are going to be your height versus your slant height. This is of this page. These two values are probably the most important. The height goes from the vertex to the base, while the slant height goes along one of the lateral faces. And so that's going to be critical for volume and surface area for today. Okay, so let's get right into this. We're just gonna add up five different pieces here, and that's all we're doing. That's all surface areas. You're just adding pieces together. Okay, so we have a regular square pyramid with a height of 15. The base edge is 16 centimeters. Find the area of each lateral face. They want the area of the lateral face. They do not want the full surface area, so it's actually easier. So, let's see here. This is 16, and they say from here to here is half of that. The reason for that, what we're doing is we're drawing the height here. And so this is going to be 8. This is an important strategy. You're going to be doing this. You need to know how to do this. So what that allows me to do is that allows me to figure out what the slant height is by using the Pythagorean theorem. L squared plus 8 squared. No, I did that wrong. Let's try again. 15 squared plus 8 squared equals L squared. So I can quickly figure out what that is. So I'm going to do 8 squared plus 15 squared. And then that's going to be, I think, 17. Yep, 17, so L equals 17. That is my slant height. Now if I look at that triangle there, we have the slant height, which is 17. We have a base of 16, so I can do 16 times 17 divided by 2, and that will be 8 times 17, which is 136. That is the area of the lateral face. Now if I want to find the full surface area, I do that times 4. Plus I'd add 16 times 16 for the square in the bottom, and that would give you your full surface area. Alright, find the surface area of a regular hexagon. So now they want the full thing. So let's start with, I guess, one of the triangles. Okay, so, and then we'll multiply that by 6. So when I look at here, I see this value, the slant height is 14, and the base is 10 of that triangle. So I can do 10 times 14 divided by 2. That would be one triangle, and then I can take that multiplied by 6. That would be the lateral area right there. That's the 6 triangles going around. Now what I need to do is find the regular hexagon on the bottom. Okay, so all right, they give us the apothem, which is 5 root 3. They give us this base, which is 10, which makes that 5. Interesting. It's 36-9 triangle. Quiz question from chapter 11. Let's see. So if I want to find the area, I'm going to do 1/2 apothem times perimeter. So plus 1/2 the apothem. They give us all the values here. 5 root 3. This is actually a really easy problem. And they give us the perimeter. The perimeter is 60. So that's really nice because they give us all the information. So I have 10 times 14 is 140. 140 divided by 2 is 70. 70 times 6 is 420. 420 plus I have, let's see, half of 60 is 30. 30 times 5 is 150. 150 root 3. And that is my exact answer. There are no decimals in it. Hopefully that sounds familiar. The book gives you guys this. They break down the net. They go through all this garbage, all this nonsense, come up with a bunch of crazy formulas. We're not going to do that. If you want to do that, you can, but I'm just going to add up the different pieces. And then we have cones, and I would normally do this with you guys in class. It's very difficult to demonstrate via video. Basically, a cone, we have a circle, and we have the lateral surface or the lateral area. And same thing here, we have slant height and height. Those are two distinguishing numbers. I'm going to get right into this. I'm going to show you guys the formula. Again, this is how the formula is derived. So if you want to look at this, you're more than welcome to. Basically, what you do is you take a cone, you cut it, and then you unroll it, and it becomes a sector of a circle. And you can do all of this here to find what that area is. And it's very complicated. It's actually very interesting and very fun to do if you're curious about deriving formulas. But this is what you guys need to know. So basically, of this page, the required material is pi r squared plus pi rl. So it's a circle on the bottom, that's pi r squared, and then it is the lateral surface area, the lateral area is pi times radius times slant height. That is L right there. So the formula is really easy to apply. It's how it's derived is complicated. We're going to just get rid of this here. We're not going to look at these answers. We're just going to find the surface area here. So we're going to do pi r squared, pi times radius squared, that's 36, plus pi times radius times L. I need my slant height. So they give me the height. So 6 squared plus 8 squared is 10 squared. So that's a 3, 4, 5 right triangle. That's why I use 10, because 3, 4, 5 times 2 is 6, 8, 10. So I have 36 pi plus 60 pi equals 96 pi. That is the exact answer. No decimals. All right, let's do one more problem here. I think that's it. Yeah, that's it after this one. So we have a cone, and it can be approximated by a right cone with radius 5.7, height of 18. Find the approximate lateral area. So again, pay attention to what the question wants. They want the lateral area, so they just want pi r l. That's all they want. They give us the radius is 5.7, and we gotta find the L, which is the slant height. And so they tell us the height is 18. They tell us the radius is 5.7. We want to find L right here. Make a triangle, use the Pythagorean theorem. I'm going to do 18 squared plus 5.7 squared. And then I'm going to square root that answer. And 18.88. So this times 18.88, that will give you your answer. Okay. All right, that's all I got for you guys. Be careful with 22 through 24. Imagine, so what they are is like, it's like, and pardon my terrible drawing here, it's like a cone and then like has like a pyramid on the top of it, and you have to find the surface area. Okay, now the reason why this is challenging, actually it should all be dotted there. The reason why this is interesting because there's 4 triangles and there is, normally there'd be 6 squares, but there's actually only 5 squares because this square right there is not part of the surface area. That is on the inside of the shape. So be very careful with 22 through 24. They're fun problems though. Okay, I'm going to stop rambling. Thanks guys.